Hello, algebra students. So we're going to skip 7-4 and go into 7-5. And 7-5 deals with linear inequalities. So far, in the last two sections and the last two sections of this unit, we've just been dealing with straight lines. And we're going to change that up a little bit. So I know last semester we dealt with inequalities. So you've solved inequalities, you've seen inequalities. Inequalities greater than, less than, greater than or equal to, less than or equal to. And so now we're going to deal with that on a two-dimensional plane. You've graphed those on straight line graphs, but you haven't graphed those on a two-dimensional plane yet. So that's what we're going to get into today. So our objective is just to graph linear inequalities. That's our objective today. Well, what are linear inequalities? They describe a region of the coordinate plane that has a boundary line. So when we're dealing with linear inequalities, we're not just dealing with a series of points in a straight line. We're dealing with a whole area of the coordinate plane that could be a possible solution to our inequality equation. And the solutions of an inequality are the coordinates of the points that make the inequality true. And you'll see a little bit more what that means when we graph a few of them. All right, so let's jump into our first example, graphing an inequality. We're going to graph y is less than 2x plus 3. And how are we going to do that? Well, if you remember, dealing with inequalities, they're much like equations. They're very similar. So the first thing we're going to do, our step one, I'm going to do this in red. Well, maybe not. Let's try this red, see if it works. All right, step one is we're going to graph the boundary line. We're just going to graph a line that where our inequality is going to have a boundary. And the way I'm going to do this is very similarly to y equals mx plus b. I'm going to start with b, my y-intercept, which is going to be 3. So I'm going to put a coordinate point here. And then I'm going to use my slope, or m, to graph a second point. So m is 2, or 2 over 1, so I'm going to go up 2 and over 1 and graph a second point. Okay. Our line isn't going to be a straight solid line. Remember when we were dealing with inequalities and the point on a line graph would either be open or closed depending on if this was equal to or not. We have a similar concept here. So because this is not equal to, we're going to draw a dashed line, and I'm going to use a straight edge just to make sure I get this pretty accurate. So this is going to be a dashed boundary line here. If it were equal to, it would be a solid boundary line. But since it's not, it's going to be dashed. All right, so we drew our boundary line. Draw a boundary line. That was our first step. Now our step 2 is going to be find the shaded region. Okay, so because this is an inequality, we have an area that's true. Either this side is going to be shaded to the boundary line or this side is going to be shaded on the boundary line. And the way we're going to determine that is by picking a point on one of these sides and plugging it in and seeing if it's true. I always like to pick the origin, 0, 0, if possible, just because it's simple, it's easy. You could pick some really high point, but you don't have to, so why? So let's pick 0, 0 and see if this ends up being true for an inequality. So 0 is less than 2 times 0 plus 3. This 2 times 0 is 0, so 0 is less than 3. Is 0 less than 3? Yes, this is true. So we know that this side of our inequality is going to be shaded, and I'm just going to do this. Okay. All right. All right, so what this is telling us that any point in this shaded region, we could put for X and Y, and it would be true. It would come out true, just like our origin did. Our boundary line, points on that line, will not come out true because it's not equal to. If it were equal to, we could use the points on the boundary line as well. But since it's not, we can't. Just the points in this shaded area here. That's what that's telling us. With solving systems of equations, our answer has always been a neat point. It's been 1 point or infinite many points or no solution. When we're dealing with inequalities, you're dealing with an infinite amount of points. So rewriting to graph an inequality. It asks us to graph 3x minus 5y is less than or equal to 10. So the first thing we're going to do is just rewrite this to look similar to slope-intercept form. Y equals. We're going to solve this for y, or y is whatever the inequality sign ends up being. So I'm going to do this in red just to make it a little bit more distinct. So the first thing I want to do is get this term with the variable by itself. So I'm going to subtract 3x here. And we solve this very much like you would an equation, but there's a little bit of a difference, which I'll get into. So far our sign just carried down. Now to get y by itself, I'm going to divide by a -5. And remember, when we divide by a negative number or multiply by a negative number, our sign changes, our sign flips. So just keep that in mind. Now y is greater than or equal to this whole side divided by -5. And because this is -3, -5, I'm going to make this positive, and I'm just going to leave it as a fraction, 3/5x. And then 10 divided by -5 is -2. So that's my final solution solved for y. Now I can graph this just like I would y equals mx plus b. Because this is equal to, my boundary line, which is my first step, is going to be a solid line. So I'm going to draw a point on -2. That's my y-intercept. My slope is 3/5, so up 3 and 1, 2, 3, 4, 5. So up 3/5 and draw my second point. And I'm going to draw my solid boundary line here. I like to use a straight edge when I'm trying to be really exact. When you're dealing with inequalities, it helps to be really precise on these. Alright, so I drew my boundary line. One more step is to find out which side of my boundary line is the shaded region. So again, I think I'm just going to put the origin into my inequality and see if it comes out true. And you could plug it into this one as well if you wanted to double check, or you could plug it into this one. It really doesn't matter. So I'm going to plug in 0, 0 here. So 0 is greater than or equal to 3/5 times 0 minus 2. 3/5 times 0 is 0, so 0 is greater than or equal to -2. Is that true? Yes. Yes, that is true. 0 is greater than -2. So I know that this side of my boundary line is my solution. And this means that any point in this shaded region or any point on the boundary line could be a solution for this inequality. All right, that's it. So thank you guys very much.